So for all these problems, we got to write the equation to find x. I'm not so worried about what equation you write as much as being able to find x and the measure of that missing angle, which is what we're going to go over. So like on a these, those two ankles have to add up to 180.
180.
So I'm going to take my 180, and if I subtract both of these, the 38, and I subtract the 88, then I would get my x value, and I'm okay with this being your equation, but that would give me 54. There we go. We can put degrees on that because x is the same as the ankle, and so we really only need one answer for this problem. So let's go over this one. Because we use the same method to solve for the ankles, and when they give us two, finding that third one really isn't too bad, because no matter which triangle it is, we're going to take 180 and subtract those two. So I'm going to subtract 110 and then 114. That's going to tell me how big this ankle is. So when I subtracted these, I get this 56 degrees right here. So this angle is 56 degrees. Now what that means is that I can take this 56, let's put it down here, and I can make it equal to 7x plus 7 to solve for x. So using all the principles of equality, which we've seen before, I'm going to subtract 7 from both sides. So that gives me the old 49er equals my 7x right here. Divide both sides by 7. And this is going to tell me what x is, 7. So two answers for this one. I've got an x at 7, and the ankle was 56 degrees. So let's write a more formal equation for this, especially since we got the two x's. So I'm going to take all three ankles. One is 5x, one is 4x, and the other ankle is 72 degrees. If I add these, how many degrees would it be? It's 180 because it's a triangle. Right there.
I thought you were going to do minus.
So yeah, actually some people said that they did not show this step, which is okay. What they would show is the next step, and that is, well, after this one, right? So I'm going to subtract 72 from both sides. What this does is it shows us how much these two ankles, the 5x and the 4x, add up to, and that appears to be 108. Now that was the 5x plus 4x. Let's combine those. So if I had 5x's and 4x's, yeah, I'd have 9x's, and this now equals 108. Now on that last one we solved for the ankle first. This one we'll have to solve for x first, because x is not actually an ankle, right here, and x is part of both ankles. So once we solve for x, then we can solve for the two missing ankles. So this question will have three answers. I'm going to divide both these by 9, and that gives me 1x equals 12. Now that's not in degrees, but this is my answer for x. So that's one answer. Alright, next we need to find those two ankles. So let's look at this 5x right here. So that'd be 5 times 12, which is 60 degrees. So that's another answer. Then we can find this ankle, 4 times 12, which is 48 degrees. And finally, just to check, we can add all these together. 60 plus 48 plus 72. And this needs to be 180, and doing the math, it does. So it checks off. Alright, let's solve this one. It's going to work the same way, except for now, instead of them giving us any of the angles, we've got to solve for x using all three ankles. And the three ankles I got a 3x, a 5x, and a 4x. The order of these is not going to matter because when I add them, it's going to give me the same thing either way. And when I do add them, I need to get 180 degrees because that's the three ankles for a triangle. So adding all three of these, 3x, 5x's, and 4x's, gives me 12 x's. And this equals 180. So to solve for just the x, I'm going to divide both sides by 12, which gives me 1x, and 1x all by itself. So 15 is one of the answers because we needed to solve for x. But now we need to solve for the ankles. So I'm going to start with the 3x. So that'd be 3 times x, which is 15. And that gives me 45 degrees. So that's one answer.
5 times
The next one I'm going to do is the 4x. So that's 4 times 15.
3 to 15. Okay.
Yeah, x is 15 for all of them. So 4 times 15 is 60 degrees. And then finally this last one is 5 times x, which is 15. And that gives us 75 degrees. And yeah, if we add all those together, we get 180. And we got all 4 answers right there. We got the x and the 3 ankles. So, on number 6, we still got the 3 angles. They're just now written in as expressions. So, all 3 of them, I'm going to start with my 5x minus 14. Then we got the x plus 32. And then the 3x plus 2.
So you first add the x.
So, we need to add all of these together. And when we do, we need to get 180. Now, we've seen problems like this before back in, I think it was Unit 3. In any case, we need to be able to just combine all these, specifically the like terms. So I'm going to start by combining the x's. I got 5 x's here, 1 x is there, and 3 x's. That gives me a total of 9 x's. Then the numbers, I got negative 14, a positive 32, and a positive 2, which appears to be a positive 20.
Equals 1.
Yeah, this is going to equal 180.
No, I get that.
Now, to solve these, we'll need to subtract 20 from both sides so that we have the x's on their own side of the equal sign. Alright, finally to solve this, for x, I'm going to divide both sides by old niner, which gives me my 1x equals, I need a calculator for that decimal. Alright, now that is the x, 17.7 repeating,
It's not oh yeah, it was.
which now allows us to solve for these other missing ankle measures. Now, just for the sake of this problem, because I can't put 7 repeating in my calculator, I'm going to say actually that I'm going to round that and say x is 17.8. Now, what this is going to do is it may give us values that are a little bit over. If we add the 3 over 180, and that's okay because we round it. All right. All right. So if x is 17.8. Then I'm going to do this ankle first, so that's 5 times 17.8 plus minus 14. So 5 times 17.8, I got 89, minus 14, 75. Now that's just that one ankle. Let's go to the next one. This x plus 32. Alright, so I got 17.8 plus 32, which should come out to 49.8 degrees. And then finally, this last one, 3x plus 2. So 3 times 17.8 plus 2. Alright, 55.4 degrees. So we got all 3 ankles. And yeah, that puts us a little over 180, but that's alright. Yeah, we got the one in red, green, and gray. And then we found our x value as well. There we go. Alright, so this one, it tells us about the triangle instead of drawing it for us, so it may be helpful to draw it, something like this. It told us one of the angles is 60 degrees. And then one ankle of a triangle is 3 times the smallest ankle. So if I said this is my smallest ankle, x, this one would have to be 3 of those x's. Now this allows me to write the equation. I've got 3x, x, and 60, which if I add I get 180. Now I can either combine like terms or get rid of that 60. So if I combine my x's, I got 4x plus 60 equals 180. And then, yeah, we'll subtract that 60 from both sides.
Equals 120, and then you.
So I got 120 equals 4x.
And you have to divide it by
Then
4.
you have
Then, yep, divide both of these
There,
by
1x.
4. So again, that gives us 1x equals 30. Now, x is one of the angles, so we're going to make that degrees. Right, that's this angle.
I really hope I can use this
30
on the
degrees.
test. This will be so.
So what would be 3 times x in this one?
You
That
might.
means this one is 90 degrees.
What? It's an acute angle.
So this one would be a right triangle, even though, I mean, it wasn't drawn that way, but it didn't matter, because we didn't know. All right, so on number 8, the sum of two angles of a triangle is 39.25. I'm going to change that into a decimal. 39.25, that's a fourth, in degrees. So the equation here, 180 minus 39.25, that's because we have the two angles. The third one is just whatever's left of the 180. So it appears that would give us, so that last angle is 140.75 degrees. The ratio of angles of a triangle is 3 to 1 to 1, so hopefully we remember this from class. We got a triangle. It's in the ratio of 3 to 1 to 1. Now if we added those together, we need, since they're angles, we need 180, so we're going to need to multiply these by something so that when we add them we can get the 180. And that will tell us the scale factor for each of these to get a total of 180. So I've got the 3x's, a 1x, and a 1x. And if I add these together, I get 180. So now let's combine all the x's. If I had 3x's, 1x, and a 1x, that would give me 5x's total, which is equal to 180. Then we'll divide both sides by 5. This is going to tell us what the scale factor is for these. So x equals 16. 36, that's much better.
Does anybody have a pencil at the bottom?
Since x is 36, then we know two of the angles were the x, so that'd be 36 degrees. Another one is 36 degrees. And then this one right here was 3 of those x's, so we'll do 3 times the 36. And that appears that it would give us 118 degrees. So there are our 3 answers, all 3 angles. So this one, instead of it giving us a ratio for all 3, they're only giving us a ratio for 2, and one of the angles is 80 degrees. So again, I can draw some kind of triangle like these. I can say that's 80 degrees. And then we need to solve these other 2, but the other 2 angles are in this ratio of 3 to 2. So 3 and 2 ratio of something. So I'm going to put an x there, multiply these by x. And so these other 2 angles, we're going to do this one a little different. The other 2 angles have to be a total of 100 degrees. Because 80 of the 180 is taken up by this angle, so we're going to subtract it out. The other 2 angles total 100 degrees. So I can make this equal to the 3x plus the 2x. And when I combine these, I get 5x's equals 100. And solving these, divide both sides by 5. And x is 20. But that doesn't really help us with, or doesn't solve for the angles yet. We got to do that still. So we're going to do 3 times 20, which is 60 degrees. That's one of the angles. And the other one will be 2 times 20, which is 40 degrees. So again, just to emphasize this, the ratio is 3 to 2, and 60 to 40 will end up being a 3:2 ratio. So they are equivalent. So yeah, we know our answer is good. Plus all three of the angles add up to 180. Phil has a lamp with a circular base that he would like to fit on a circular side table in his house. The area of the base of the lamp is 70 inches squared. So that's the lamp. The table has a radius of 5 inches. We got to figure out if the area of the table is enough for the lamp to fit. Now, we're not asking if it will balance on there. We're just asking if it will fit on the surface of the table. So, we know the area of the lamp is 70. So we got to find the table area. So let's figure out the area of the surface of that table. So that area, it already told us the radius is 5. So I got 5 times 5, radius times pi. And that will tell me the area of the table. Alright, so I got 78.5 rounded in inches squared. That gives us an extra 3.5 square inches for the lamp. So will the lamp fit? The answer is yes. And we showed our work.
Oh, that's
The circumference of a pizza is 81. What is the radius?
81 divided by 2.
Well, we got to figure out what the diameter is first.
Oh, that's the diameter.
And the diameter is the circumference divided by pi. Well, in this case, they gave us the circumference, which was 81. So 81 divided by pi. Alright, so this goes back to the lesson. If the circumference is the diameter times pi, if we want the diameter, we just divide both sides by pi. And these two pi's cancel out, leaving us with just the diameter. That is how or why we divide by pi. Now, we didn't want the diameter, though. We wanted the radius. So we're going to have to divide both of these by 2, which will give us the radius. So dividing by 2, and I got 12.89 inches. That would be the radius. Alright, so the circumference is 200 feet on this hot tub. And just going back to that last problem, the diameter is the circumference divided by pi. And we know the circumference on this one is 200 feet. So I'm just going to replace my circumference with 200 and plug this into my calculator. So 63.66 inches is the diameter. We need to divide both these by 2 to get the radius. So that gives us a radius of... So if this is the radius, 31.83... Oh, this is feet, not inches. I put inches.
Like the tuber.
And I'm not ready to go to the camp.
Alright, you guys are right. This is a humongous hot tub. I don't know where these exist, but whatever.
Oh, I heard hot
In my basement.
The area of this, though, is going to be 31.83 times 31.83
circular.
multiplied by pi. And that will tell me the area in square feet. A pizza place charges $12 for a 12-inch pizza, $14 for a 14-inch pizza, and $16 for a 16-inch pizza, $20 for a 20-inch pizza. What is the best deal? So this is the diameters that they're giving us. What we need to do is figure out the area. Then we can find the unit rate for how many dollars it is for 1 square inch of this stuff. So let's start with our 12-inch pizza. So if 12-inch pizza, that's the diameter, so the radius is going to be 6. So the area is going to be 6 times 6 times a pi.
So wouldn't it be like $1 an inch?
So that's 113.1 square inches. And to find the unit rate, square inches per dollar, I'm going to divide this by $12. So that gives me my unit rate in square inches per dollar, just for the 12-inch pizza though. So next up, we'll do the 14-inch pizza. The 14-inch pizza has a radius of 7. So I got 7 times 7 times pi, which is going to give me the area. So with 153.9 inches squared, I'm going to divide this by the dollars. This one was $14. Alright, so I got 11 after I rounded this. It was 10.99557, some garbage. That's 11 square inches for every $1. So far, which of these is the better deal? It's the 14-inch pizza, because right now you're getting more square inches for every $1 that you pay. 16 inches of pizza gives us a radius of 8. So I got 8 times 8 times pi. Let's just run through this process, okay, because we're going to divide that by $16 for 16 inches. So that's 201. I rounded it to 0.1 there for 16 bucks. Alright, so 12.6 inches squared for $1. So right now the 16-inch pizza is the best deal. But then finally we got the 20-incher. It's pretty big. Alright, so just skipping the math on that, but showing it. It looks like the 20-inch pizza is going to be 15.7 square inches for every $1. So clearly that one is the best deal.